there. Today we are going to review some of the skills that we've been learning in our unit on adding and subtracting fractions. So I'm going to review each of these skills, and then you guys are going to get a chance to practice. So we're going to review adding and subtracting fractions using area models, adding and subtracting fractions numerically by finding a common denominator, adding mixed numbers, subtracting a fraction or mixed number from a whole number, and subtracting mixed numbers. All right, let's get started. All right, so I am going to show you how to add fractions using an area model. Well, not show you, but review. So I want to add 3/4 plus 1/5. So what I'm going to do is I'm going to start by putting my 3/4 in my first area model, and I'm going to use vertical lines to make my fourths. 1, 2, 3 lines. So now it's split into fourths, and I'm going to shade in 3 of them. 1, 2, and 3. Try to shade it in all the way. Okay. So I'm going to label that I have 3/4. And now I'm going to do my 1/5 in my second model, but I'm going to use horizontal lines to partition. So I'm going to draw 4 horizontal lines. 1, 2, 3, 4 to get fifths. And I will shade in 1 to show 1/5. Okay, now I'm going to take these horizontal lines that I drew on my second model, and I'm going to draw them on my first. So I'm going to draw 4 horizontal lines. 1, 2, 3, 4. And then the 3 vertical lines I drew on my first model, I'm going to draw on my second. 1, 2, 3. And now I've partitioned the 2 models into the same number of parts. I have 20 parts in each. So my new denominator is 20 for each one. Okay, so now let's figure out how many 20ths are equivalent to each of my original fractions. So in the first model, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 20ths shaded, which means that 3/4 is equivalent to 15 20ths. And then here on my second model, I can see that I have 4 20ths shaded, which is equivalent to 1/5. So now to add, I just need to do 15 20ths plus 4 20ths, and I get 19 20ths. So I can say that 3/4 plus 1/5 is equivalent to 19 20ths, and that's my answer. All right, moving on to subtracting fractions using area models. So I'm going to use the same strategy. So I want to do 2/3 minus 1/2. So on my first model, I'm going to use vertical lines to make thirds. I'll shade in 2. 1 and 2. I'll label that 2/3. And on my second model, I'm going to draw a horizontal line to shade into 1/2. Okay, so now I'm going to take the horizontal line I put on my second model and I'm going to draw on my first. And then the vertical lines I drew on my first model, I'm going to draw on my second. And now I can see that I have the same number of parts in each model, which is 6. So now I'm going to figure out how many 6 each of these fractions is equivalent to. Well, here in my first model, I can count. I can see that I have 4 6 shaded. And in my second model, I can see that I have 3 6 shaded. So I'm going to do 4 6 minus 3 6. I'm just rewriting my original equation using my new equivalent fractions. I could even cross out on my first model. I could cross out 3 6, and I could see that I have 1 6 left shaded, or I could just subtract across, and I would have 1 6 left. So I can say that 2/3 minus 1/2 is equivalent or is equal to 1 6. Now I want to add fractions numerically. So I'm just going to do that with numbers, and I'm not going to use area models this time. So the first thing I want to do is I want to skip count by the 2 denominators to find the least common denominator. So I'm going to skip count by 4, and I want to skip count by 6. This helps me so that if I find the least common denominator, then I don't have to simplify my fraction at the end because I'm already finding the least common denominator. So skip count by 4, 4, 8, 12, 16. Just going to skip count out a little bit. Now for 6, 6, 12, 18. And I can see that the least common denominator, or the least common multiple, is 12. Okay, so now I need to make equivalent fractions for each of these fractions with a denominator of 12. And I'm going to do that by multiplying. So let's figure out how many 12ths 3/4 is equivalent to. Well, I know that 4 times 3 is 12. So if I multiply the denominator by 3, I have to multiply the numerator by 3. So that's equivalent to 9/12. And I'm going to do the same with 5 6. So 5 6, let's figure out how many 12ths that's equivalent to. So I know that 6 times 2 is 12. So I need to multiply the numerator times 2. 5 times 2 is 10. So now I'm going to add my 2 equivalent fractions. So instead of 3/4, I'll write 9/12. And instead of 5 6, I can write 10/12. And now I can add because I have the same denominator. So 9/12 plus 10/12 is 19/12. I notice that that is a fraction greater than 1 because the numerator is greater than the denominator. So I'm going to rewrite that as, well, let's think. 12 goes into 19 one time, and there's a remainder 7. So 1 and 7/12 is my answer. All right. Now I'm going to do the same strategy to subtract fractions numerically. So I want to do 7/10 minus 1/3. So first thing I want to do is skip count by the 2 denominators to find the least common denominator. So let's count by 10, 10, 20, 30, 40, 50. Let's count by 3, 3, 6, 9, 12, 15, 18. I'm going to keep going because I don't see a common denominator yet. 21, 24, 27, 30. Okay, we found a common denominator. 30 is the lowest common denominator. So that means that I need to make equivalent fractions with each of my numbers in the equation, each of my fractions, with a denominator of 30. So let's see how many 30ths 7/10 is equivalent to. So I know that 10 times 3 is 30. So I need to multiply the numerator by 3. 7 times 3 is 21. So 7/10 is equal to 21/30. Let's do the same with 1/3. Let's see, 1/3 is equal to how many 30ths? 3 times 10 is 30. So I need to do 1 times 10, which is 10. So 1/3 is equal to 10/30. So now I can very easily subtract, and I'm doing 21/30 minus 10/30, and I get 11/30. And I cannot simplify that because they do not have a common factor. So 7/10 minus 1/3 is 11/30. Okay, I'm going to show you guys how to add mixed numbers, or remind you how to add mixed numbers. So I like to do whole number, fraction, and then the attachment. So if I'm doing the whole numbers, I'm just doing 4 plus 1, which is equal to 5. Easy peasy. If I'm doing the fractions, I like to do it numerically. If you wanted to do it with an area model, that would work too. So I'm going to skip count by 3 and 5 to find a common denominator. So I'm going to go 3, 6, 9, 12, 15, 18. All right, 5, 10, 15. So we already found a common denominator, which is 15. All right, so I'm going to make equivalent fractions with 15 as the denominator. So 2/3 is equal to how many 15ths? Well, I know that 3 times 5 is 15. So 2 times 5 is 10. So 2/3 is equivalent to 10/15. Now I'll do the same with 2/5. 2/5 is equal to how many 15ths? Well, 5 times 3 is 15. So 2 times 3 is 6. So 2/5 is equal to 6/15. So now I'm going to add 10/15 plus 6/15, which is equal to 16/15. I notice that that's a fraction greater than 1, so I'm going to rewrite it as a mixed number. 15 goes into 16 one time with the remainder 1, so it's 1 and 1/15. So now I need to attach or combine the 5 from my whole number sum and the 1 and 1/15 from my fraction sum. And I get 6 and 1/15. And that's it. So 4 and 2/3 plus 1 and 2/5 is 6 and 1/15. And that makes sense, right? Like it's about 6. 4 plus 1 is 5, but it's 4 and 2/3, so it's almost at 5. So this answer makes sense. It's reasonable. I want to subtract a mixed number from a whole number. While number lines might not be the best strategy to solve, they can help you picture which two whole numbers your answer would lie between. So one thing that you might be compelled to do is just to say, okay, 4 minus 2 is 2, so the answer would be 2 2/7. That does not work. That would work, that kind of thinking would work for adding. If I wanted to add 4 plus 2 2/7, I would get 6 2/7. I could add the whole numbers and then just leave the fraction. Let me show you on a number line why that would work for addition but not subtraction. So if I'm starting at 4 and I want to first add 2, so a jump of 2, and then I want to make a jump of 2/7. I'm just approximating here. I would land at 6 2/7. So that would work. But why this doesn't work for subtracting is, say I'm at 4. First, I'm going to make a jump backwards of 2. And then I need to make a jump backwards of 2/7. Should be about here. So my answer would actually lie between 1 and 2 holes. So 2 2/7 is between 2 and 3 holes. That would be like right here. As you can see on the number line, first I made a jump backwards of 2, then I made a jump backwards of 2/7. So my answer is going to be between 1 and 2 holes. So that will not work. You can't just subtract the whole numbers and then leave the fraction there. That will not work. So let's see what we can do. Let me erase all of this actually. Let me show you what we can do. So you could do it by drawing. I know that this works well for some students. So I can draw 4 holes. Then I know that I need to take away 2 of them. And then I need to take away 2/7 from the next one. But I don't have 7ths here, so I need to break it up into 7ths. So I'm going to draw 6 lines to break it up into 7ths. 1, 2, 3, 4, 5, 6. And then I can take away 2/7. And I can see what I have left is 1 hole and 5/7. Another strategy I could use is to, if I'm doing 4 minus 2 2/7, is I could rewrite the 4 as 3 7/7. Let's pause and think about why that makes sense. Why can I do that? Well, 7/7 is equivalent to 1 whole, and 3 plus 1 equals 4. So 3 7/7 has the same value of 4, but it would just make it a lot easier for me to subtract that 2 2/7. So if I'm doing 3 7/7 minus 2 2/7, I know that 3 minus 2 is 1. 7/7 minus 2/7 is 5/7. So it's actually very similar to what I did with the picture. I just took one of the holes and I split it into 7 parts. And I thought of it as 7/7 instead of 1 whole, and that helped me subtract. And that is how you subtract a mixed number or a fraction from a whole number. So now I'm going to use a very similar concept to subtract mixed numbers. So one strategy I can use for subtracting mixed numbers is I can take my 7, if I want to do 7 1/5 minus 4 1/3. And some of you might be able to see right away that 1/5 is smaller than 1/3. So if I just tried to find a common denominator and subtract that way, it wouldn't work because 1/5 is smaller. So I'm going to need to regroup some from the 7 holes. If you are not able to just see right away that 1/5 is smaller than 1/3, use these strategies anyways for subtracting mixed numbers. It'll work regardless. So these are pretty safe bet strategies for subtracting mixed numbers. All right, let me show you how now. So I'm going to take this 7 and I'm going to regroup one whole from it. I'm going to rewrite it as 6 and 5/5. I chose fifths because that's the fraction I have, that's the denominator I have with my mixed number in 7 and 1/5. And I can rewrite the 7 as 6 and 5/5 because 5/5 is equal to 1 whole and 6 and 1 make 7. Now I'm going to combine the 5/5 and 1/5 to make 6/5. And then I'll keep this whole number 6. So really 7 and 1/5 is the same value as 6 and 6/5. And now I'm going to want to subtract my 4 and 1/3. Now I can go ahead, find a common denominator, make equivalent fractions, and subtract. So I'll find my common denominator of 5 and 3. So I can do 5, 10, 15, 20. Some of you might be able to start finding common denominators in your head, which would be great. But for those of you who are still working on that mental math, this works too. 3, 6, 9, 12, 15. So a common denominator is 15. So now I'll make equivalent fractions with my 6/5 and my 1/3. So 6/5 is equivalent to how many 15ths? Well, 5 times 3 is 15. So I need to multiply 6 by 3. I get 18. I'll do the same with 1/3. 1/3 is equal to how many 15ths? Well, I know 3 times 5 is 15. So I need to do 1 times 5, which is 5. So now I can rewrite this equation as 6 and 18/15 minus 4 and 5/15. And I get, okay, well, 6 minus 4 is 2. 18/15 minus 5/15 is 13/15. And there you go. 2 and 13/15. One other strategy you could use for subtracting mixed numbers is taking the original mixed numbers and rewriting them as fractions greater than 1. So I can rewrite 7 and 1/5 as, well, let's think. 7 times 5 is 35. 35 plus 1 is 36. So I can rewrite this as 36/5. And then I can rewrite 4 and 1/3 as, well, 4 times 3 is 12. 12 plus 1 is 13, so 13/3. Then I can just find common denominators and subtract. I already figured out that 15 is the lowest common denominator, so now I'll need to make equivalent fractions. So 36/5, let's figure out how many 15ths that's equal to. So 5 times 3 is 15, so I need to multiply 36 times 3, which is 108. And then I'm going to do the same with 13/3 is equal to how many 15ths? So 3 times 5 is 15, so I need to do 13 times 5. I'm going to do that up here real quick. 13 times 5, 15, 5 times 1 is 5, plus 1 is 6, so 65. And then I can do 108/15. Oopsies. 108/15 minus 65/15. And I'm going to subtract over here on the side. 108 minus 65 is 3. 10 minus 6 is 4. 43/15. And I can rewrite that as a mixed number, so I can think 15 goes into 43 2 times, the remainder of 13. So 2 and 13/15, same answer. So either strategy works. You just need to pick which one works best for you, which one you like the most, you're going to be more successful with, and go from there. It's always good to have a repertoire of strategies. So I hope this review helped and that you guys get some practice and thrive in your adding and subtracting fractions.